This lesson is on cyclonic storms and weather analysis. So here's a reiteration of high and low pressure areas. We need to remember for this lesson that when warm air rises, it does so in a counterclockwise motion, creating an area of low pressure below. And when cool air descends, it does so in a clockwise motion, creating an area of high pressure below. So this is going to play into our knowledge on how cyclonic storms such as hurricanes form. Okay, let's talk a little bit about tropical storms. So tropical storms are large, rotating, low-pressure storms. So you have these areas where warm air is rising away from the surface, and because of that counterclockwise rotation of the rising warm, moist air, it kind of gives it feeds into what can eventually grow into one of these tropical storms or hurricanes. All right, so tropical storms, like I was beginning to say, they form in a low pressure system when water evaporates off of warm tropical waters. This creates a region of low pressure, which is attracting surrounding air because remember, air wants to flow from high pressure areas to low pressure areas. So when you get these very large areas of warm ocean water evaporating and warm air rising and creating a big, vast, low pressure area, you've got all this other air that's drawn into it. And like I say, it starts feeding what could become a tropical storm or even hurricane. The rotation of the earth, the Coriolis effect, this is what also makes the storm begin to spin or feeds into that motion. All right, so here you can kind of see that going on. You have this warm, moist air coming up, and you get these different parcels of air moving these different directions, and it's just kind of like, almost like inertia. Like you get air moving in a certain direction, and you get these high and low pressure areas kind of working together with each other, and just feeds into this storm that does not want to quit as long as warm evaporating ocean water and the air holding that water vapor keeps feeding the storm. All right, let's talk about like kind of the anatomy of the hurricane. All right, so the eye of the hurricane is the center of it. And in the eye here, the hurricane is actually relatively calm. So if you've ever been through a hurricane, you might have noticed that the hurricane starts off, you start to see the weather effects, and the storm increases and increases in intensity, and then all of a sudden there's this period of relative calm, and sometimes it almost seems like the hurricane's over with. It's passed over you and it's gone, but in reality you're just in the eye of it, and then you're about to go through, as the storm passes over your area, you're about to go through the same thing again. It's just you're going through the other side of the hurricane. All right, the eye wall is basically the walls of the eye of the hurricane. This is the band surrounding the eye, and it has the strongest winds. So let's say you were, in a location and this hurricane started to pass over you. Like I said, you're going to start to experience, as this part of the hurricane out here, the outer part starts to pass over you, you're going to start experiencing weather associated with hurricanes. And that weather, as this hurricane moves over you, as you get closer to the eye wall, it's going to increase in intensity. And then if the eye is over you, you're going to experience like a period of relative calm. It may fool you into thinking that the hurricane is over with or it's totally passed over you, but then you get, that intensity returns, whenever you hit the other side of this the eye wall here. And then eventually, as the hurricane passes over you and then the edges are over you, the intensity of the storm decreases and eventually you're out of its path. All right, so hurricanes are classified according to the Saffir-Simpson hurricane scale. It's kind of like when we were talking about earthquakes, and they're classified based on the Richter scale. Hurricanes are classified on this scale. And this scale measures wind speed, air pressure, storm surge level, and the potential for property damage. And you can see here you have like the categories. You've heard of these on the news whenever a hurricane's headed our way. And that the categories, as you go up in numbers, the intensity of the storm is greater and greater. Here you can see here that the wind is greater, the pressure differences are markedly different from a 1 to a 5, And then here we have the storm surge. They're talking about how much feet that sea level is gonna rise there at the coast due to the surge of the storm. And you can see that you can have 18 feet or greater with a Category 5 hurricane. So that's a very significant storm surge. All right, so how does the hurricane end? I just said earlier that, as long as there's warm evaporating ocean water feeding this hurricane, it tends to go. And the hurricane will last until it can no longer produce enough energy to sustain itself, or when there's not any more evaporating warm water and air feeding it. So usually that's going to happen when a hurricane moves over land or cool water and there's no evaporating water to feed it, like I've been saying. Now, there have been some hurricanes, they move over land and they're able, because they were so strong, they're able to keep going for a very long time over land. But eventually they do weaken and come to an end because, like I said, they don't have adequate evaporating warm water to feed it anymore. All right, that storm surge, we've been talking about these. They occur when hurricane force winds drive a big mound of ocean water toward coastal areas. Basically, as I said, it was like a localized, increase in sea level. These can reach 6 meters above normal sea level. So this can flood coastal cities and towns, like what you're seeing in the picture here with this house. All right, hurricane preparation. So fortunately for us, where we live, we're far enough inland, we can experience some pretty significant hurricane weather, but it's nothing quite like being at the coast, unless the hurricane is very, very strong still when it reaches us. So hurricanes can be observed from weather satellites orbiting the Earth, and that has improved hurricane warnings. We know when they're on their way. It gives people time to leave coastal areas that are going to be directly hit or very directly impacted by the hurricane. And allows the rest of us to prepare in ways we need to. At the coast, boarding up houses so the windows are not broken is a thing. Staying indoors, evacuating if necessary. In a lot of cases, evacuation is necessary. I have a lot of friends that live in Wilmington, and hurricanes affect Wilmington, fairly often. And they often have to make a decision. Is this do I need to evacuate, or is this one we can ride out? Is this going to be very strong and potentially kill us, or is it or is this one we can ride out and be safe, or we're going to be safe indoors? It's just something they have to assess and make a decision on. Having plenty of food and water available to you is good, and of course, like I was saying, staying away from windows, trying to stay in central location of whatever structure you're inside of while you're riding out the hurricane. The Galveston hurricane is an example of a large hurricane that happened in 1900. It's a Category 4 hurricane, and it's believed to have created one of the greatest loss of life in the history of hurricanes. And you can see here, this one, it began here in the Atlantic and it reached here and hit the coast of Texas. And this one actually continued to go over land, all right, for this long and then back out to sea again before it ended. Hurricane Katrina was a very historic hurricane. It hit New Orleans, Louisiana, which I'm not sure if we've talked about yet in class, but the problem with New Orleans is the city is actually below sea level, and the only reason it isn't flooded is because of this barrier called the levee that's holding the water back. And what happened with this hurricane is that the levee was broke basically, or was the water level rose above it. The levee failed and caused almost 2,000 deaths. It's considered to be the deadliest hurricane since 1928. And I don't believe we've had one quite as destructive in terms of loss of life as this in sense. But if you've been watching, paying attention to the news recently, you know that we've had many, many hurricanes hit the United States since, and that the impact, the destruction and loss of life and so on and so forth, it has definitely been, has been great. All right, let's move on to weather analysis. So a general rule is that the accuracy of weather prediction is going to decline with time, meaning it's easier to accurately predict the weather of the coming hours or days than it is to predict the weather of the coming weeks or months. When it comes to weeks and months, you can kind of make some predictions, but things can definitely change. But when you're talking about the next day or two, the next few hours, the forecasters can be a lot more accurate. So the sooner, like the closer in time you're forecasting, generally the better the forecast is going to be, the more accurate. But trying to ascertain what's going to happen in the coming weeks or months is a lot harder, and the accuracy goes down significantly. Meteorologists use the following tools to gather information about weather conditions. Now, there's more tools than we're going to talk about today, but we're going to talk about the most common ones. Thermometers, of course, which measure temperature. Barometers, which measure air pressure. Anemometers, which measure wind speed and direction. Meteorologists also make use of radiosondes. These are kind of like a little box of instruments. It kind of looks like a little box like take-in food might come in, but it's full of these weather instruments that are these sensors and probes that they make measurements of conditions in the upper atmosphere and transmit the information back down to the meteorologists so that they can predict what's going to happen based on all of those conditions. We also use radar, which is used to track precipitation. It can tell wind speeds. It can tell the direction that precipitation is traveling in. Doppler radar is the one you always hear about talked about on the news. They really like to brag on their Doppler radar systems, which make use of the Doppler effect, which are changes in the wave frequency when waves move forward or away. And like I said, this can tell a lot of things like wind speeds, the direction of movement of fronts, and weather events such as precipitation of all sorts. Satellites that orbit the Earth are also used to predict weather and monitor weather. They provide good images of cloud cover. They can detect thermal energy. They have, that you can see thermal images that show you the warmer and the colder areas. They represent those differences of color. We've seen that before when we were looking at the ocean floor when we were studying volcanoes. You could see the hotter areas were in colors like reds and purples, and the cooler areas were like greens and yellows and blues. So they can be used also to determine a cloud's temperature and what type of cloud it is. So the satellites are really good at helping us, track what's going on and predict what will occur in the future. A station model is a record of weather data for a specific location and time that's represented in a series of numbers and symbols. And the point of this is so that a meteorologist can quickly record some information and pass it on to another one elsewhere. And then that other meteorologist can just take a quick glance at the station model and just gather so much information without having to read a lengthy description or anything like that. So it allows us to convey a lot of information in a short amount of time and in a small amount of space. Now here we have a legend surrounding this station model. It tells us what the symbols indicate, like type of cloud, type of high clouds, barometric pressure, change in barometric pressure in the last 3 hours, wind speed and direction, the type of low clouds, dew point temperature, type of precipitation, temperature, and type of middle clouds. Now, when a meteorologist will send this or look at this, this legend won't be here, but they do this so often they know what all of these mean, like right off the top of their head. They don't need the legend anymore. So it's a very quick, efficient way of conveying lots of information. All right, meteorologists also use ISO lines on weather maps to show areas of similar weather conditions. You've definitely seen this on the news if you ever watched the weather forecast. So ISO lines are used to connect areas of either the same pressure or same temperature. ISO lines that connect points of equal pressure are known as ISO bars. All right, that's what we have in this picture here. Okay, because we know we're not talking about 1,000 degrees Celsius or Fahrenheit temperatures, right? That would be out of control. We don't see that, right? That we couldn't even live under those conditions. So we know we're talking about barometric pressure. Okay, so like within this line here, or along this line here, that's an area, an area of equal barometric pressure, and then out here in this ring, that's another area of equal barometric pressure, and so on and so forth. Like and you can see this is a low pressure area, as indicated by this L here. Now, on the other hand, we have iso lines that connect points of equal temperature, and those we refer to as isotherms, and you can see those here in this picture. So here we have temperature in degrees Fahrenheit, and you can see here, like right along, this little corridor here, as you might refer to it as, you have 90 degrees, and then along this other one here, you have 85 degrees, 80 degrees, 75, so on and so forth. And one of the last point to reiterate, the surface winds tend to flow counterclockwise inward toward a center of low pressure.